Tensile test is carried out to ascertain strength and ductility of a material. The specimen is held in self-aligning grips of a tensile testing machine and subjected to a gradually increasing load. An extensometer is provided to give extension readings of the specimen while the load is gradually increased. With the values of extension with respect to load, the stress-strain curve can be drawn. As the load increases, the specimen gets fractured. After breakage, the broken ends are fitted. The distance between the reference marks and the smallest diameter are measured. Hardness can be determined by Brinell hardness test. This test consists of indenting the surface of a specimen by means of a 10 mm hardened steel ball under load. Duration of load application is 15 seconds. The Brinell number is a function of load applied and indentation area. The diameter of the indentation is found by a low-powered microscope. In Brinell hardness test, Brinell number is given by the ratio of load and indentation area. The indentation area is measured by a microscope. Significance of hardness number is that it gives a measure of resistance to wear. This test is useful for determining differences in materials due to heat treatment that would not be indicated by the tensile test. A notched test piece is gripped in a vise and is fractured by means of swinging hammer. After the specimen is fractured, the hammer arm engages with the pointer, which is carried for the remainder of the swinging arm travel. At the completion of the hammer swing, the pointer is disengaged. The reading indicated by the pointer is the energy required to fracture the specimen. Usually 3 tests are carried out on the same specimen, and the average energy is taken as the impact strength value. The objective of creep test is to calculate limiting creep stress. This test measures and records stress, strain, temperature, and time. The creep stress consists of applying a fixed load to a test piece and maintaining it at a uniform temperature. One platinum wire and platinum tube is spot welded to the specimen. The wire slides inside the tube and both contains reference marks. Elongation of reference marks are measured on the scale inside a telescope. The elongation of reference marks is recorded at the desired time interval for the entire duration of the test. The values are plotted in a graph to obtain the creep curve. The limiting creep stress of the material is calculated from the curve. A fatigue testing machine simulates the stress conditions developed in a machinery component parts by varying the cyclic loads. The magnitude of stress is changed in the machine. The setup consists of an electric motor capable of running at 10,000 RPM, an appropriate bearing which relieves the electric motor of the large bending moment, chuck to hold the specimen, rotating lever arm subjected to a downward force in order to place a specimen in bending state. The revolution counter measures the number of revolutions the specimen has undergone. Because of lever arm subjected to a downward force, the upper surface of the specimen remains in tension and lower surface remains in compression. While the specimen is rotated at higher speeds at any given position, the specimen is subjected to alternate compressive and tensile stresses. The test is carried out on similar specimens of the same material at different loads, and number of stress reversals to fracture the specimen is noted. The results are plotted on a graph from which fatigue limit is calculated. Logarithmic scale is adopted to condense the graph. This test is carried out by bending a straight specimen of plate through 180 degrees around a former. For the test to be satisfactory, no cracks should occur at the outer surface of the plate. Significance of this test is that it is carried out in boilerplate materials, because boiler is a fired pressure vessel.